We'll get started in a couple minutes. As people are joining, welcome. We're just going to give it another minute or two to get critical mass. Again, thank you for joining us this morning, and we'll get started in a minute. All right. It looks like we have critical mass. So again, thank you very much for joining the Watershed Institute's Technical Friday, Stormwater Design, Myth, and Misconceptions. My name is Mike Pissarro. I am the Policy Director here at the Watershed Institute. If you don't know about the Watershed Institute, we're a nonprofit environmental organization in central New Jersey. Keeping water clean, safe, and healthy is the heart of our mission. We've been running these Technical Fridays for the last couple of years to provide increased knowledge and awareness of the issues, at least along water and watersheds. We have multiple programs, but conservation, advocacy, education, and science are our departments. And now for some webinar logistics. We are recording. We will send you the recording in a follow-up email, and it will be available on our website and our YouTube channel. If you have a question during this webinar, please put it in the Q&A button or section of Zoom. We will get to those. Usually what we do is get to the questions at the end, but I may stop one of our presenters if there's a question I think that really needs to be addressed right then and there because it shows something wasn't clear. Again, thank you for participating in these programs. We do these to increase the professionals, municipal officials, environmental advocate, and community members' knowledge of these issues, because these are the issues that really are affecting us day to day. So if you are a professional engineer, we are able to give you PE credits. We've been approved by the board to provide PE credits. There will be a link shortly on the attendance form. Please complete that and return it. Once we receive the attendance form and confirm that you've actually attended it, we will send you out a certificate of attendance. Please send those certificates to polivera@thewatershed.org. And if you have any questions, please pop those into the Q&A. Our land acknowledgement. Oops, sorry. We recognize that the land and water now under our care is the traditional and ancestral territory of the Lenape. We pay respect to the Lenape peoples, past, present, and future, and their continuing presence in the homeland and throughout the Lenape diaspora. We respect the knowledge, culture, and tradition which have contributed to the conservation of land and water. Now, today we have two great panelist speakers, Gabe Mann. He's graduated from the Lafayette College in 2004. He is currently the Borough Chief of the New Jersey Department of Environmental Protection, NJPTE Stormwater Permitting and Water Quality Management, and has been presenting on stormwater for several years and has been a very generous speaker at our Watershed Institute programming. So Gabe, thank you. And we have Clay Emerson. He is a senior technical director at Princeton Hydro, where he focuses on all things hydrology, stormwater, and flooding. Clay does a lot of stormwater reviews, but he also does stormwater design. With that, I'm going to turn this over to Gabe, and we can start the program. Again, if you have questions, please pop them into the Q&A, and we will get to them at the very least at the end. So everyone, thank you. And Gabe, go ahead.
All right. Thanks, Mike. Good morning, everyone. I'm just gonna share my screen really quickly. Mike, can you see that now? All right.
Yes, I can.
Okay.
Yeah.
All right. So, like Mike said, my name is Gabriel Mann, and I am the manager of the Bureau of Najipti's Stormwater Permitting and Water Quality Management, which is in the newly created Division of Watershed Protection and Restoration at the NJDEP. In my bureau, we oversee the MS4 program, the Municipal Separate Storm Sewer Program, as well as the industrial stormwater program and the state's water quality management planning program. Additionally, our staff manage the stormwater rules and the BMP manual and everything that goes along with that. So really, pretty much everything stormwater in the state goes through my bureau. And what I'm going to be doing today is going over some common design issues that we see. We at the department really are not designing projects per se, but we are reviewing them. And so we see these issues in the designs that we are reviewing. I have 9 examples that I'm going to go over. Some of these are really simple and straightforward. Some of the later ones are a little longer. But for the most part, these are the most common issues that we're seeing. And a lot of them can be corrected pretty easily by just knowing about the issues and thinking about them a little more than sometimes they're thought about. So the issues that I'm going to go over basically are improper selection of the land cover, improper pre-treatment of BMPs, failure to treat certain areas of the properties, particularly entrance and exit drives, deviations from the approved plan, improper groundwater recharge exemptions, the green infrastructure requirement not being fully addressed, not doing an appropriate maintenance plan, improper use of the new updated and projected rainfall data, and then inappropriately issued variances. So the first one is going to be the improper land cover designation. So I'm going to go over a little example here, but basically first let's take a look at the rules. So the project that we're going to talk about, now it was approved some years ago. This is not a new project. It's actually one that predates the green infrastructure requirements of the rules. It's not particularly important to the example, to be honest, but just keep that in mind. If you have any questions about why the design looks this way, it's because it predates those rules. So the important thing here is that when you look to the rules, and there's a section in the rules about how you do your calculations, it tells you that when you select your runoff coefficients, you have to basically assume it's forest, or if the design engineer verifies that the hydrologic condition has existed on for 5 years in the site, you can use a different runoff coefficient that reflects that condition that's been there for 5 years. It goes on to explain that if more than one land cover has existed in the 5 years immediately prior to the time of application, then you have to select the land cover with the lowest runoff potential. And that makes logical sense, right? If we're trying to make sure you're not having adverse impacts from stormwater leaving the property, you want to look at the land cover that had the lowest runoff potential, because most likely, if you're subject to these rules, right, you're going to be adding impervious coverage or something that's going to increase the runoff potential. So you're looking at the lowest and comparing it to your post-development. So that's the biggest change that you could see. So that's going to provide for the most, protections to water quality and preventing flooding and such, if you look at it that way. And so that's what the rules require. So this is the example. Like I said, it's a little older of a design, so the site plan's not as clear as some of the newer ones you might see. But what the important thing is, the parts all along the bottom here, this is all existing down here, and this is the proposed. So it looks like they're proposing this building here and a bit of a parking lot in this area. And then I can switch over to show what the aerial photos of this site look like. And again, like I said, this was an older one. So I think we reviewed this back in about like 2013 or something like that, 2014. So that's why we're looking back to these older aerial photos. So if we take a look at the comparison between the aerial photos that were out there in 2007 and 2012, and these are what's available on our GIS, so I didn't particularly choose these dates for any reason other than they were the closest that we had to this. So the design engineer, in their calculations, they said this land is already mostly impervious coverage, and when we look at the calculations, it's not increasing by more than a quarter acre, so we don't have to do water quality. Recharge deficit is very small. And also importantly, there was a Category 1 water course near this site. And because that Category 1 water course because this is older, right? This doesn't have the most current revisions to the stormwater rules in mind. we still had the SWRPA in the rules at this time. So the SWRPA was a 300-foot buffer, similar to the 300-foot riparian zone we have in the flood hazard rules now. And that was in the stormwater rules at the time. So that was something that was required to be implemented here because it was over a quarter-acre increase. But based on the engineers' calculations, it wasn't, because they based it on the 2007 where it was already paved. But the reality was the site, when they were developing it, looked like this. The building and the parking lot that were previously there had already been removed. So this was the conditions that the rules required them to look at. Like I said, you have to look at the lowest land cover in the previous 5 years, and this was what just predated the application. So all of that stuff should have been counted as new impervious coverage. It should have triggered the water quality requirements, and it should have triggered that SWRPA requirement for the 300-foot buffer from the Category 1 water, and that would have actually required the water quality to be 95% TSS removal instead of the 80% that would have otherwise been required if there was no Category 1 water. So you do have to keep in mind that you're looking at the correct land cover to use. All right, that's pretty much that example.
Gabe, let me just
Yep.
jump in very quickly.
Mhm.
Trying to be better at this, you use SWRPA, which I know doesn't exist anymore, but can you
Yeah.
tell people what SWRPA is?
Yeah, sure. So SWRPA it stands for, first of all, Special Water Resource Protection Area, and it's a 300-foot buffer from Category 1 waters that required, it had limits on how much disturbance you could do in there, and also had enhanced water quality requirements. Now, that was a requirement in the stormwater management rules up until 2016. And at that time, it was just merged with the Flood Hazard Area Control Act's 300-foot riparian zone. So now the 95% TSS removal and the limited disturbance in the 300-foot riparian zone, all that stuff still applies. It's just no longer contained within the stormwater rules. We had the 300-foot buffer in the stormwater rules, and we had also that other 300-foot buffer in the flood hazard rules. So it was just onerous. So we combined them together to have one clear standard and implement in one rule set. So all those requirements still apply. They just apply through the flood hazard rules instead.
Great. And Gabe, just one quick, there was a question about this slide. A question, it seemed odd that so much trees grew up in a 5-year period. Or how accurate are these, the aerials?
Well, yeah, that's a good question. I didn't consider that before. I think there are some trees down here. This one looks like it was taken in winter to me, so probably these trees down here, you just don't see the foliage. This one up here, I'm not sure about. That might have been a new tree in those 5 years. But I do agree, it seems to be awfully large for that. But it just may be a matter of that you can't see it here in the aerial photo for some reason.
All right, great, thank you.
All right, so moving on to issue number 2. This is a pretty simple one. It is about pre-treatment for stormwater BMPs. There are several stormwater BMPs that if you're going to use them, they require pre-treatment. This is an example of the pre-treatment we saw in an example that we received. So this project, which again predates the green infrastructure rules. So they were using a sand filter with an underdrain, which wouldn't be considered green infrastructure today. So wouldn't be really an option unless they got some sort of waiver or variance. But they were able to use it back then. So that's what they were using this time. But a sand filter requires pre-treatment. That's mandatory in our BMP manual. And I'll show that on the next slide. But this is the pre-treatment they provided to us, an inlet with a snout. And that's not really going to meet the requirements of pre-treatment. So we'll take a look at what the BMP manual says. So you can see that from our current BMP manual, and this requirement was the same back then, that pre-treatment is a requirement for all sand filters. And if you look down to the bottom here, you can see that the pre-treatment can consist of a forebay or any other BMP found in Chapter 9 or 11. So basically, this means you could use any one of our BMPs for pre-treatment. You can use an MPD, you can use a vegetated filter strip, you can use a grass swale, you can use a bioretention basin or another type of basin. That could be your pre-treatment for a sand filter, or it can be a forebay. And a forebay is going to have to require that it stores 10% of the water quality design storm volume in that forebay. So if we look back to this proposed pre-treatment, there's no way that this inlet stores 10% of the water quality design storm volume that goes to this basin. It's not a sufficient substitution for a forebay. But this was approved by the municipality. So this is one of the things we saw in one of our MS4 audits, and it's just an example of insufficient pre-treatment. Now, pre-treatment has become a more important concept in recent years as well, because We do have an allowance in the BMP manual now to let exfiltration be used, so you can account for your infiltration that's happening in the routings of your calculations. We didn't previously allow anyone to do that, but you can do that now for certain types of basins. But in those cases, pretreatment is generally a requirement. So it's important that the pretreatment be appropriate. Pretreatment can't just be an inlet that you oversize or something like that. That's not sufficient pretreatment. All right, so next example I'm going to go over is runoff from entrances and exits. This is what the site looks like in existing conditions. You can see that the site itself is like about 1.5 acres. There's some woody vegetation on some sides of the property, but for the most part, it's pretty cleared already. In existing conditions, the stormwater is going to flow off in 3 different ways. You've got stormwater flowing off to the left side here, which is actually the south, and stormwater flowing off to the bottom, and stormwater flowing off to the top. And those are 3 separate drainage areas. So when you're doing your calculations, you really need to look at those 3 separate drainage areas to make sure that you're meeting the requirements. Now, in this case, and this is the same example I got that sand filter from, so in this case, the soils are not really conducive to infiltration here. So what they've chosen to do is to use that underdrained sand filter, which is up here. They also have an underdrained bioretention basin over here. So we can still see that they've sort of maintained those 3 drainage areas. At least this one down here is still going down in this direction. This one over here is still going in this direction. This one's not really flowing off in this direction anymore. What happens is it goes into this basin and then flows out here and down and around and connects down to this one. It's not actually prohibited. So that's something that we can accept. But the important thing to look at here is this drainage area. You can see that there's no basin over here. You've got a bioretention basin here providing treatment and quantity reductions. You got the sand filter up here providing water quality treatment and quantity reductions, and making sure they meet all the requirements before the discharge over here. But on this side, there's just nothing. The water from this entrance drive just flows back out into the street and down. Well, that obviously doesn't meet the water quality requirements. Even if the peak flow reductions for the whole site meet, this is problematic because they didn't meet the peak flow reductions for water quantity in this section, right? And anyone that potentially owns property or is driving through this street here is subject to possibly additional flooding because there's no water quantity control in this here. Now, you know, we do offer some minor amounts of flexibility in these sorts of designs. Sometimes if you look here, you know, it might be impossible to capture like this last little strip right here of their entrance drive. So we might let that go. But in a case like this is like a very large area to be let go. We would never be able to approve this. But again, this is something we saw in one of our MS4 audits that the municipality did approve. So that's really something that's got to be looked at. This does not meet the water quality or quantity requirements. Okay, so another example I want to show is about deviations from the plans that are approved. So on this site, in the calculations that we received, they basically said the site was completely or like mostly paved over. And as you can see on the left-hand side, it's a little small, but this area right here in the center, that's like a pool that's been abandoned. So certainly that was an impervious area. There were also a few buildings that were in the property around then. But then if we look to the right, that's the aerial photo that we saw of the site when we were actually reviewing this. So this is what's on the plans, but this is the aerial photo of the actual site. So even though the plans are showing a lot of impervious and some stuff there, like the aerial photo shows that there's a bit more pervious area out there than it looked like on the plans. Now, that's not the main focus of this though. So if we take a look over at the actual calculations they provided to us, what they're showing is that there was 1.61 acres of pavement, you know, parking lot, roof, driveway, impervious coverage in existing conditions, and about a ½ acre of lawn. And then the proposed coverage, they were going to go to 1.83 acres of impervious coverage and about 0.3 acres or so of lawn. So if you take a look at these numbers and do the math, you're going to find out that they're increasing the impervious coverage by about 0.22 acres. Now, again, this is another example that does predate some of our most recent changes to the stormwater rules. So right now, we look at the increase in motor vehicle surface to determine whether or not you trigger water quality, but that's a change that we made in 2020. So right now, at the time of this application, we just looked at the increase in total impervious coverage to determine whether or not you triggered water quality. And so like I said, in this example, their calculations And it's important to stress that it's their calculations that say that they're increasing by 0.22 acres. So that's less than a quarter acre, just barely, but it's less than a quarter acre. And this project, based on that, would not have to meet the water quality requirement. So if we take a look at the plans more closely of what they're proposing, you can see that this area here has got a pretty big island, and some of the other areas around there, like strips of vegetation around the side. And that's where they're really maintaining their pervious coverage in their proposal. The disturbance for this project is definitely over the acre. So regardless of whether or not it's over the quarter acre, it's still a major development and got a review at the municipality. But the issue that we saw is that when this is actually constructed, these are the actual plans that they wound up building the site to. Well, you can see that the grassed area that we were talking about here is gone. There was a little strip over here too that I think is gone. And when you add this all up, because they were so close to the quarter acre, just the loss of those little island areas now puts them over the quarter acre. But the municipality never revised what they were looking at and didn't require them to do water quality. So this project wound up not doing water quality, even though it was actually over the quarter acre trigger. And you can see in the aerial photos that they never built those grassed areas that they were supposed to do. And in fact, they built another small building here as well, eliminating even more of the pervious area that they were supposed to have on the property. So ultimately, this project should have been addressing the water quality requirement, but it did not because of those discrepancies between what they put in their calculations and what they actually built out there on the property. So it's important that you make sure both that, if you're the reviewer anyway, or the designer, that both your calculations match what you're putting on the plans, but also that ultimately what's on the plans is what's built, because none of the information in your stormwater report really matters if that's not what you actually build on the property.
And Gabe,
Yeah.
going back to that, what would if you can answer this, what would a municipality do? Would this would seem to me require that the applicant come back for a modification of the planning board or the zoning board's approval, and then I'm guessing it would require maybe ripping up some of that impervious and putting back for stormwater management, or
Yeah, I think they would have some options there, right? They could have them go back and just rip some up to try and match more closely what they were approved for, get themselves under the quarter acre, not have to do water quality. But the other option would be to just make them do water quality. Once something is built like this, it's not going to be that easy to suddenly add your water quality treatment, but you might be able to find a way to put a manufactured treatment device somewhere in your system or something like that to be able to meet the water quality requirements. But I think the applicant would be put in a difficult situation. They would have to do one or the other because they're not meeting the standards. So as the municipality, you really don't want to let this sort of thing slide, because it's not, when we come to audit a municipality, we're not going to go to this developer and tell them they built it improperly. That's not how the MS4 program works. The MS4 program is a permit to the municipality to ensure the municipality makes people do their stormwater appropriately. So if we were to issue a violation about this, it would be to the municipality for not having this property properly meet the stormwater management requirements. So the municipality is the one that winds up being on the hook for not making them do this. So the municipality really needs to go ahead and force them to do one of those options, either fix it and put it back to the way they approved it, or to add water quality treatment.
Great, thank you.
Okay. Another issue that we see very often, this one is definitely one that has confused people for a long time. It is about the groundwater recharge exemption in the urban redevelopment area. So in this case, it's a project that disturbed more than 1 acre, so it triggers the stormwater management rules. Importantly, when you're over the acre, you trigger both the water quantity standard and the groundwater recharge standard. Again, this is a little bit of an older project as well, so we didn't have the green infrastructure requirement, but today you would also trigger the green infrastructure requirement. So let's look at what's required here, because there is an exemption from groundwater recharge specifically within the urban redevelopment area. And one thing you have to be careful about when you read the rules is that certain terms have definitions, right? Urban redevelopment area, you might just think any urban area that's being redeveloped gets exempt, but that's not the case. Urban redevelopment area has a definition in the stormwater management rules, and you need to look to that definition to know what areas qualify for this exemption. And specifically, and highlighted in red, are some of the important points. Urban redevelopment area is defined as previously developed portions of areas designated on the state policy plan map as planning area 1. And that one's in red because that's the biggest one we see. Sometimes there's designated centers, cores, and nodes, but those certainly don't come up as often. Same thing with CAFRA, cores, centers, and nodes, urban enterprise zones, and urban coordinating council empowerment neighborhoods. For the most part, I don't see anyone even try to make arguments that they are in those zones. I'm not even sure what the last one is, to be honest. But importantly, it has to be previously developed portions of these areas. So they can be exempt if it's a previously developed portion of a planning area 1. But in this example that I want to show, I'm going to show the aerial photo now of the site. Well, it's 2 lots, and 1 lot does have a single family home on it, but they're proposing to basically clear this whole thing. And you can see this one has nothing on it. It's just a forest lot. They're proposing to clear the whole thing, and the municipality approved this as exempt from the groundwater recharge requirement. Now, did they do that appropriately? I don't think so, right? How can you claim that this is previously developed? You certainly can't. Even if you want to make the argument, and you can make the argument that this section and wherever their driveway happens to be that you can't really see through the forest cover here, the tree cover, are previously developed, that's fine. Those areas are previously developed and would meet the definition of previously developed portions of a planning area 1. But just because you have some amount of development on a site doesn't make the entire site qualify for that exemption. It's only the previously developed portions that qualify for that exemption. Now, there is confusion about what's considered previously developed, especially when something was, say, developed a long time ago and hasn't been touched for a very long time, and vegetation has reestablished on the site. So we do have some clarification we offer in one of our frequently asked questions about this. And basically what we say is, if there's woody vegetation that's reestablished there, it's no longer considered previously developed. So if you have grassland areas, maybe some small shrubs and flowers and stuff growing there, that's fine. That could still be considered previously developed. Once you have woody vegetation reestablishing itself in that area, it's no longer considered previously developed. And it does take a little while for that to happen. So if the property was just developed 2 or 3 years ago, it's not going to have woody vegetation established on it. But if it's left alone for 10 or 15 years, then you're likely to see that it's no longer considered previously developed and wouldn't qualify for this exemption anymore. All right. So moving on, I'm going to talk about the green infrastructure requirement. First thing I want to do is talk briefly about a fact sheet that we came out for the green infrastructure requirement to help explain what's necessary to meet this. So the fact sheet answers a few questions. What is GI? Why is it important? Then also I'm going to show you where the fact sheet's posted and what the stormwater management rules say about GI, and then how is GI supposed to be implemented. All right, so first, where's the fact sheet posted? So this is pretty straightforward. If you look to the Stormwater BMP manual page, you're going to find it at the very bottom down here. This is the link. You can just use the link, or you can go to njstormwater.org, which is what I usually do to find all this stuff, and just click the BMP manual page. Yep, and that's highlighted there. Okay, and so you can also use this link here that's in the top. That takes you directly to the document. And this is the way it'll look. It talks about meeting the green infrastructure requirements. First goes over the drainage area limits, talks about what is green infrastructure. It's not a particularly long document. It's just about 8 pages. It's supposed to be just informative to help people meet this standard. All right, so let's take a look at what the rules say about green infrastructure. So this is straight from the rules. So the minimum, and importantly, it says here, the minimum design and performance standards for groundwater recharge, stormwater runoff quality, and stormwater runoff quantity have to be met by incorporating green infrastructure. Okay, so they shall be met, which means mandatory, by incorporating green infrastructure. And it highlight this, it shows it's all of the requirements. Recharge, quality, and quantity all have to be met by using green infrastructure. Some of the confusion we often see here is that people want to meet groundwater recharge and quality using green infrastructure, but don't understand that they also need to meet the quantity standard using green infrastructure. We do have several classifications of BMPs that are green infrastructure, both small scale and large scale. You can use the large scale to meet your quantity requirements, which is the difference, but they still always need to be green infrastructure. Now, what makes a BMP small scale is that they have, for the most part, not everyone does, but I'll explain that in a minute, but they have contributory drainage area limits. So we have a definition of contributory drainage area limit for if there's any confusion about what that means. And it's defined as the area which stormwater runoff drains to a stormwater management measure. And importantly, not including the area of the stormwater management measure itself. So you can have a BMP that's an acre in size, and you can have the entire contributory drainage area limit still drain to that, and that's okay because the BMP area itself doesn't push it over the limit as it's not counted towards the contributory drainage area. Okay, so this shows what the contributory drainage areas are for the BMPs. So for a dry well, it's 1 acre. For pretty much everything else, it's 2.5 acres, except for pervious paving, which allows 3 times the area of your pervious paving to flow onto it. So if you have 1 acre of pervious paving, you can have 3 acres of regular pavement flow onto that area of pervious paving, and that would meet the drainage area limit. Okay, so getting back to how we implement the GI requirement and the fact sheet. The fact sheet outlines basically that there are these 3 questions that you should ask when reviewing or designing a project. And if you can answer yes to all of them, then you're going to meet the GI requirement. If you answer no to any one of these, that's a problem, and the project really doesn't meet the GI requirements. So the first one we're going to talk about is stormwater met close to the source. So what is meant by close to the source? So this is an example I have we created. It's just a parking lot in a building and 1 big stormwater management basin. Now let's assume for this example that this is a large site, right? This is not a tiny parking lot. This is a Walmart or another large box store where they have a big parking lot, a big building, and they just have 1 stormwater management basin tucked over in the corner. Well, if we take a look at where the stormwater is going to be coming from, flowing from here all the way down to that basin, it's not really close to the source. Now, you can make an argument for the stormwater from right here that it's close to the source, but it's not close to the source for all the stormwater for this site. So it might, if it was a BMP and it was just treating this area, then maybe you could argue, yes, it's close to the source and it's green infrastructure and that meets the requirement, but you would have to have some other BMPs over here to treat the rest of it because it's not close to the source for the rest of the property. So this is not GI. This does not meet the standard because we're answering no to that very first question. All right, so this is an example of how GI can be managed close to the source. Now, this is an example from our BMP manual, and this is one that incorporates literally every type of GI that you could into a site like this. You most likely do not need all of this to actually comply with the requirement, but this is a really good example of what can be done, and you can pick and choose which things work for your property. So this has green roof for the building. It has a cistern underground. It has pervious paving here. It really incorporates everything you could fit into this type of design. And this certainly would meet the GI requirements. And this is what it looks like in plan view as well. You can see that there's really GI distributed all throughout the site. You got the green roof, you got the cistern, you've got your pervious paving all throughout here. You've even got stormwater islands in between this area over here that is impervious paving. So this would meet the GI requirement because this would be managing stormwater close to its source. Your impervious surface here, it's getting managed close to its source here. Obviously, the green roof is going to manage things close to its source because that's the stormwater falls directly onto it. And you're going to have close to the source here. There's nothing in this scenario where the stormwater is flowing all the way across the site to get to the place where it's being treated. That's not the case here. All right, so here's another example that we have from our BMP manual. This is a simpler example. All we're using here is just permeable pavement in this case. So you just have a simple building and a parking lot, and you used pervious paving in the parking spaces. And again, you ask yourself the question, well, is this going to be treated close to the source? And are the BMPs distributed? Yeah, we've moved on to the second question here, actually. So are the BMPs distributed throughout the site? And you can say the same thing here. Yes, it's going to be close to the source. You've got the parking aisles being treated by the parking spaces. They're very close to one another. The building is going down into those same areas as well. And are they distributed throughout the site? I think the answer here also is yes. You've got GI BMPs here, GI BMP here, GI BMP here. It's distributed around throughout the site. And that is one of the actually greatest things I think about pervious paving. It is the simplest BMP to easily distribute throughout your site. If you're going to have pavement on your site, which almost every development we see is going to have pavement all around various areas of the site. You make that pervious paving, then you suddenly have GI BMPs that are distributed throughout the entire site. Let's show another example about BMPs distributed throughout the site. So this is a simple look at just a building with dry wells surrounding it. There's a couple reasons I want to talk about this one. So first of all, as we touched on before, a dry well has a 1 acre drainage area limit. So if we assume this building is less than 7 acres because we've got 7 dry wells here, then conceivably that's enough dry wells to manage this building. All you need to do then is make sure that each one of the dry wells doesn't have more than 1 acre draining to it, and it'll meet that contributory drainage area limit. Then we'll have to ask ourselves, well, is it close to the source? Certainly it's close to the source here. These dry wells are right around the building, which is the source. And then are they distributed? Now, if this is the only development that they're doing, yes, you could easily say this is distributed throughout the site. You've got dry wells surrounding, 3 of the 4 sides of this building, so it's pretty well distributed. The one thing that you would have to make sure if you're looking at a design like this is that each dry well functions individually. You don't want to construct something where it's really just one dry well that's all interconnected. You want this, otherwise that's not really meeting the drainage area limit anymore. You just need to make sure that the water quality design storm and the groundwater recharge design storm, which are the storms that are subject to the small scale green infrastructure, are functioning individually. These dry wells are functioning individually during those storms. And then this would qualify as being distributed throughout the site. It would meet the drainage area limit. If this was the whole site, it's going to meet the green infrastructure requirement. Well, assuming it meets the quantity control requirement, which you probably couldn't do with just dry wells, but depends on exactly what the existing conditions were. So let's take a look at a few examples of what doesn't meet the site, doesn't meet the GI requirements. This is one, and this is something that we saw very often right at the beginning of the implementation of the GI requirements. And I think for the most part, we saw this a lot then because people were trying to take site designs that they had already done and trying to just tweak them so they could meet the green infrastructure requirement. And this is one of the ways they tried to do this. And why they created all these small scale BMPs is so they could meet that drainage area limit. So this is kind of the same example we looked at the beginning, where you have a lot of impervious surface flowing down over here. Probably this was over the 2.5 acres and couldn't all just drain to one BMP because it wouldn't meet the drainage area limit. So they just made a bunch of small BMPs in front of it to sort of act as the water quality BMPs that would overflow to the large scale BMP. But again, if we ask ourselves those 3 questions that we need to ask, are BMPs distributed throughout the site? Well, you're going to have to answer no to that question. And right off the bat, we might as well not even ask the other questions, because once you say no to one of them, it really doesn't meet the GI requirement at that point. So this is not going to qualify as green infrastructure. This is another example. This is just a simple example where you can see you've got small BMPs distributed out through all the areas. So as long as you're able to make sure that each of these bioretention basins, again, thinking back to what the limit was, they have a 2.5 acre drainage area limit. So as long as each one of these has less than 2.5 acres draining to it, you can say, yes, it meets the drainage area limits. Yes, these are distributed throughout the site. So you're going to be able to argue that, yes, this kind of a design would meet the GI requirement. Now, again, you may not need each and every one of these in order to meet your stormwater requirements, but that's just an example of how you could distribute bioretention throughout a site and meet the requirement. All right. So moving on, and keeping in mind, actually, there was one other thing I wanted to mention there. I forgot to mention it, so let me back up to this slide. So one question that we sometimes get, and it applies to basically this and to this kind of design, is can these BMPs be so close to one another? Now, because we're asking for BMPs to be distributed throughout the site, it would seem like the answer to that is no, but it's not necessarily no. In a case like this, they're distributed. Yes, they are close to each other, but if this was the whole entire site, then it's distributed throughout the site and they can be close to each other. There's no specific requirement that a BMP needs to be some distance from another BMP. As long as it's distributed throughout the site, it's okay. So it's okay in this example, and it's okay that the BMPs are near each other. The reason it's not okay here is not because they're so close to one another, it's because they're all so close to one another and concentrated in this corner of the site. If 2 of these were over here and they happen to be close to each other, that's acceptable as long as the BMPs are distributed throughout the entire site. So keep that in mind. There's not a limit on how close they can be to each other. It's just about being distributed, meeting the green infrastructure requirement. All right. So quickly, a couple of issues that we're seeing with maintenance plans. So you are required to have a maintenance plan with any application that you submit, and the maintenance plan has to have specific tasks and schedules of maintenance. It has to have cost estimates for sediment removal, debris removal, trash removal, and importantly, the name, address, and telephone number of the person responsible for doing the maintenance. Here's some examples of what are preventative and corrective tasks, keeping in mind that preventative tasks are things that you do, in advance of damage, and corrective tasks are things that you would do after damage has occurred, maybe from a storm or if a car accidentally drove into your BMP or something like that. So you would want to have all this listed out in your maintenance plan. You also have to have a place, a log or something where you can store the maintenance records, and you have to annually evaluate, the owner of the basin has to annually evaluate the effectiveness of the maintenance plan. On top of that, BMP manuals in Chapter 8, 9, and 10 lists various things that need to be incorporated into the manual. Chapter 8 is basically all about maintenance and retrofit of BMP, so that talks more generically about it. But as you get into Chapters 9, 10, and 11, that's where you have each individual type of BMP, and there's specific tasks that are important for each type of BMP. Like, for example, if you have a detention basin, you're going to have to cut the grass on some certain frequency. But if you have a different kind of basin that doesn't have grass, obviously, that's not going to be a requirement that's in there. So you need to look to that and make sure that the maintenance plan matches the BMP that you're putting in there and has the appropriate maintenance. So also, it's important to note that a maintenance plan needs to be recorded on the deed. Now, it's not a deed restriction that needs to be placed. There is definitely some confusion about that sometimes, but it's just needs to be recorded on the deed so that when someone looks to the deed of this property, they'll see that there's this type of BMP there, and this is the maintenance that needs to be done to make sure that it still functions. Yeah, another thing to note here is that oftentimes when we see an application up front, the maintenance plan will say the developer is going to be the one that maintains it, but in the long run, that's usually not the case, especially if it's a residential development. Most often those are going to be turned over to a homeowners association. So if you wind up recording the maintenance plan that says it's the developer, and then you turn it over to a homeowners association, you do have to make sure you go back and get that changed so that it shows the right responsible party. So I'm going to show a couple examples of bad maintenance plans and talk briefly about why they're not great. So first, this is an example that we don't see as much anymore, but definitely have seen a lot of these throughout the years. And that is where they try to put the maintenance on a plan sheet of the plans for the design. So if we start talking about and thinking back about all the requirements that need to be in there, you need to have a log, you need to have cost estimates, you need to have preventative and you need to have those tasks incorporated in there. When you think about that, it really doesn't work to be on a single plan page of your stormwater management plans. It doesn't make a lot of sense. On top of that, even though it's not necessarily specifically a requirement in the rules, we should be thinking about how someone is going to use this plan. Is someone going to use your maintenance plan by going back to the plan sheets of the design and recording when they did the maintenance on there and looking back at that to see what maintenance they have to do? No, that's not really realistic. What's important is that you want this basin that you're designing, you're paying all this money to design, to install. It's supposed to prevent water quality impacts. It's supposed to prevent flooding. And none of that's going to happen if it's not properly maintained. So you really want to create a separate maintenance plan, a booklet or something that the ultimate owner of the basin can have so they're able to use it and it's useful to them to make sure that the maintenance is getting done and a place to record what's happening. So the one page, on your plans is just not going to work out. Now, this is another example, and you might think, okay, this is a 55-page example. You might think, all right, this one's going to be great. Well, in this case that we're talking about, specifically, this BMP was a constructed wetland. So if you start looking at what things are listed in here for the preventative maintenance procedures, grass cutting, it doesn't really sound like that's great. Specifically talks about maintenance of a stormwater detention facility. Well, that's not the right name for it. So that's kind of concerning to me. So this is a maintenance for a constructed wetland, but if we look through all 55 pages here, nothing ever talks about a constructed wetland. On top of that, this had no responsible party contact information. It didn't really have the preventative tasks that were associated with a constructed wetland. Didn't have the cost estimates for maintenance, for dredging, for anything they would have to do for maintenance of the system. So this, even though it's a 55-page plan, really isn't going to have the information necessary to maintain this BMP. Okay. Now moving on, getting close to the end of my presentation, just a couple more things to go over. I'm going to talk about the updated and projected rainfall data. So the stormwater management rules that we adopted in July 17th, 2023 include updates to rainfall data that need to be used in the runoff calculations. So there's two things that we've incorporated. One is an update that updates the rainfall from 99 to 2019. That's when we had the Northeast Regional Climate Center do the study for us to update the rainfall. And the reason we did that is because if you just use NOAA data is based on 1999 is the last year that's incorporated into the NOAA data calculation of what's like the 210 and 100-year storm for a site. So now this updates that to 2019, and you can see that in some places there's very minor changes. This is a 1% change, but if you get up to here in Warren County for the 100-year storm, well, there was actually a 15% change just based on updating that information. And the second thing we've also done is to project the rainfall out to the year 2099. And the reason we're doing this is so that we can have basins function now using today's rainfall and make sure that they're going to function for their entire lifetime. Because if rainfall increases significantly over the course of the lifespan of your BMP, and it's not sized to handle that, well, as that rainfall increases and increases and increases, now your basin is no longer mitigating the same level of risk. So there's more and more and more risk of flooding near your site as the years go up and the rainfall increases. So now we're trying to make sure that BMPs are designed to mitigate that risk going forward. Here's a quick example of what it looks like to do this calculation. So this is just an example for the 2-year storm. So if we look here, 2-year, 24-hour, because we're using the 24-hour storms, you can see that from NOAA, and that's what this chart is from NOAA, the rainfall is 3.3. So we'll put that in as our NOAA data, 3.3. And we'll look back. This is for Mercer County. So we'll look back to the 2-year storm in Mercer County. So it's 1.01. So you take that 3.3, multiply by 1.01, and you get 3.36. So not much of a change there for the 2-year storm. And that's for the current, the 2019 data. Then we'll also do the same thing for the projected. If we look back here, we're going to just go over to this table instead. Mercer County 2-year storm, it's 1.16. And you do the same thing. And the important thing I want to point out here is that you're always applying both multiplication factors to the NOAA data. You do not apply the future projected to the updated rainfall you've calculated. It's always applied back to the NOAA data. Okay, so again, why is this important? Because the quantity control requirement now in our most recent amendments to the rules requires that you do your quantity control based on the 210 and 100-year storms for both the current and projected rainfall. Now, what I want to point out basically is that the way you do this is you take your current rainfall, you figure out you take your rainfall from NOAA, you figure out what your current updated rainfall is. So that'll be our 3.36 from our example. And you use that to calculate the runoff leaving the site in existing and proposed conditions. Now for the 2-year storm, your proposed has to be 50% or less of existing. So that would be your target. But this again is both existing and proposed using that current rainfall. And then you do the same thing again using the projected rainfall. You calculate existing and proposed using that projected rainfall, and your proposed needs to be 50% or lower of the pre-construction condition calculation. You do not, and this is confusion, and this is basically what I want to clear up, is you do not use current rainfall for existing conditions and projected rainfall for proposed. I've had that question posed to me many times, and that is not what you do. It's always comparing the same rainfall to the same rainfall. So it's current to current, proposed to proposed, or sorry, current to current and projected to projected. It's never current to projected. All right. So I'm just going to go over the last example I have, and that's about variances and exemptions. So first of all, what is a variance and what is an exemption? So an exemption is very specific term in the rules. There are really 3 exemptions. At 5.2D in our stormwater management rules and at 5.2E, there are 2 exemptions. 5.2D is exemptions for utilities, so like underground utilities, above ground utilities. There's certain restrictions on what you can do, but those are exempt from the quantity, quality, and groundwater recharge standards. 5.2E is a waiver of strict compliance, really, but it can be an exemption. And that's specifically for roadway projects. So if you're widening a roadway and you can't quite meet one of the standards, you can go under 5.2E and you can get an exemption or a reduction in the requirements for one of those standards. And also there's the groundwater recharge exemption that we previously discussed. There are no other exemptions in the stormwater management rules. And the same holds true for people's local stormwater control ordinances. They might not be in the same citation, in fact, they won't be. It won't be 5.2D in their ordinance or 5.2E, but the same language will be there somewhere. But no other exemptions exist. I often get people that contact me and they say, hey, we need an exemption from this. We need an exemption from that. We need an exemption from this. I'm like, okay, well, what exemption in the rules are you talking about? I can't just give out exemptions. I can only follow the rules. That's what we're mandated to do. We're mandated to implement the stormwater management rules. If you qualify for an exemption in the rule, great. We'll talk about that. But if you don't qualify for those exemptions, and they are quite limited, there's nothing I can do. I can't just exempt you from some other standard. Now, a variance is a little different. A municipality can grant a variance from any criteria, but they have to meet the requirements at 7:8-4.6. I'll talk really quickly about what that is. So first of all, in order to do it, they have to have a mitigation plan within their municipal stormwater management plan. The applicant has to demonstrate it's technically infeasible to meet the standard on site. The applicant has to achieve the maximum possible compliance on site. So it's not maximum practicable or any other word, it's maximum possible. And then the applicant has to propose and construct a mitigation project that complies with the mitigation component of their municipal stormwater management plan. So for technical infeasibility, only engineering, environmental, or safety reasons can be considered. Cost, and it's intentionally left out, cost is not a reason to demonstrate technical infeasibility. So someone can argue, hey, for all these engineering reasons, it's just impossible for me to meet the standard on site for whatever, I don't know, just as a generic example. And that would be okay if they can make that case. They can't say it costs too much to meet this requirement on site. That's not acceptable and would not be an appropriate use of the variance. Another thing to keep in mind is it applies only to the individual drainage area and design and performance standard you're talking about, right? You're making the case it's technically infeasible for me to meet water quality in this drainage area of the site. That doesn't mean you just don't do water quality for the whole site. It just means you just get out of it doing it right there in that one little section where you demonstrated that. Now, it could apply to the entire site, but you would have to make that demonstration for each drainage area on the site. If it had the same situation on all the drainage areas, perhaps you could make that argument. But you have to make that argument. It's not an automatic thing for the whole site. Now, last thing to talk about is when you go through this variance process, there has to be mitigation. Mitigation is not optional. It's required for all variances. The mitigation project can be something from the municipal mitigation plan if that lists projects, or it can be proposed by the applicant. Either way is acceptable, but either way, there has to be a mitigation project. And it has to mitigate for the design and performance standard that got the variance. So if we go back to the one I just briefly mentioned, didn't meet water quality in one of the drainage areas, well, then your variance needs to make up for that. Let's say you were required to do 80% and you were only able to do 40%. So you need to do that extra 40% you couldn't do on your property. You need to do that off-site somewhere in the same HUC 14 and make up for what you didn't do on the site. It doesn't get you out of the requirement to do a variance. It just lets you do it off-site instead. So you're still going to have to make up for that off-site. Now, one of the questions I see a lot these days is trying to get variances from the green infrastructure standard. And we have a couple of these where municipalities have approved them and they weren't approved appropriately. And so now we're in the process of getting that straightened out. So you can get a variance from the GI standard at the municipal level. That's a possibility. But again, you first have to demonstrate it's technically infeasible to meet GI. And I've yet to see an example where someone demonstrated that it was technically infeasible to use GI on their property. But let's say, for example, somehow they're able to prove that. The rules outline what you have to do to make up for that. And you have to construct an offsite project that provides GI that treats equal or greater amount of impervious surface and motor vehicle surface. So let's say your site had 2 acres of impervious surface total, one of which was motor vehicle surface. Well, if you're going to do your stormwater on site, you're going to do it with non-GI because you've proved it's technically infeasible to use GI somehow, but you're still going to do your stormwater management, your quality, your quantity, and your recharge on site using non-GI. Well, you got this variance, and it's going to require you to do a mitigation project offsite for that GI that you didn't do on site. So now you need to go offsite. You need to find 2 acres of impervious surface, one of which is motor vehicle surface at least, and you're going to have to then use GI to manage that. So basically, if you are able to get this variance, it's not really something that most people are going to want to do because it requires you to basically do your stormwater on site and your stormwater off site. The only way that you could not do the stormwater on site is you also prove that it was technically infeasible to meet the standards themselves, the quantity, quality, and recharge. Just proving that you can't do GI on site still means you can meet those using non-GI and forces you to do GI offsite, requiring you to basically treat your stormwater twice. So really that only makes sense in some sort of rare case where it's actually technically infeasible to do it on site. All right, and that's it for me. Clay's going to bring up a few more examples. My contact information is here. If any questions come up, you can always email me or call our office. And that will be it for me.
Gabe, thank you very much. And as Clay brings up, I'm going to take a stab at answering one of these sort of questions. There was a question as Clay's bringing up his presentations. So, whether the maintenance plan is sort of the municipality is required to receive and record the annual review of effectiveness of maintenance plans. So maintenance plans are extremely important in my mind because towns under the MS4 permit are required to show that they have a program to enforce the maintenance and effectiveness of that maintenance plan for private systems. So if the township doesn't have the maintenance plan and they don't know what systems are existing out in the wild, so to speak, in their municipality, it's virtually impossible for them to, at their annual certification, show that they have a program and they're enforcing the program. That's my opinion as a lawyer and as an advocate. So towns, when they approve projects to the planning board or zoning board, should be having those plans, should be keeping records of those plans and keeping records of who the property owners are who are responsible. And with that, I am going to throw it over to Clay for his presentation. We have a lot of great questions. Please keep putting those in the Q&A and we will get to as many of them as possible at the end. So thank you.
Okay. Thanks a lot, Mike, and thanks a lot, Gabe, for that excellent presentation. There's always something that I'm learning on these too. And I think one I see some of the comments coming in and listening to Gabe's presentation. I think the regulations do a good job at making things as black and white, as clear as possible. But as Gabe kind of alluded to in some of the examples, there's a limit to that. And at some point there is some gray area, but we need to use common sense and so you'll see that in some of the comments that I have here as well. So just a little bit, Mike asked me to focus on myths and misconceptions, things that people sometimes get wrong, things that Gabe and I, in our different but similar lines of work come across that we see time and time again. So I've kind of broken that up roughly into 4 different subsections. In doing this, I kind of had to cut myself off because I could have made an entire presentation really on any one of these topics. But I've tried to just give a little bit of information on each one of them. And the purpose of this presentation, and maybe to a greater extent the whole webinar, like I said, is to give some attention to these things that often are missed. And looking at the attendance, the people who we expected to attend, we definitely have a mixed group. I expect there's designers, I expect there's reviewers, I expect there's engineers, I expect there's maybe some elected officials and a mix of municipal representatives. So I think there'll be something for everyone in here. And I've tried to keep it accessible as possible in terms of the content. So yeah, my first kind of subtopic here or issue is, as Gabe outlined his presentation, is existing conditions. And I think far too little attention gets paid to existing conditions. When from a reviewer standpoint, for example, when the plans come in, the first thing you do is you flip to the stormwater page and you see where are they putting the basin, how big is the basin, what kind of systems are they using, where's their green infrastructure. Or if you open up the stormwater management report, you're instantly flipping to the table that summarizes the peak flow rates. Is this number 80% of that number? Check the box. And what I tell both, especially from a review capacity, is don't bother reviewing, or if you're designing, don't bother designing any post-development or even really thinking about any post-development elements until the existing conditions are properly represented. So from a review standpoint, if they have problems with the existing conditions, you can throw the rest of the stuff out. You never need to look at it until that's resolved. From a design perspective, you're doing yourself a disservice because you may, come to a reviewer who notices that you messed up your existing conditions, and all that work that went into sizing, grading, all those details that go into that, the outlet structure. You may find yourself in a tough predicament going backwards there. So, yeah, so proper representation of the existing conditions sets the bar, uh, arguably for two of the three primary performance requirements. So there's runoff quantity. I call it peak flow control. I'll rant about that later. Groundwater recharge, and then to a lesser extent, water quality. The existing conditions don't have as much influence on that, so I've let that go here. But these two items, it has a huge impact on. So how so? And I'll talk a little bit more about why it's important, if I haven't already. But an existing site's runoff characteristics are highly dependent on the soil and land cover of the property, you know, pre-development before the proposed applications. So what that means is that paving over well-drained areas has a bigger downstream impact than paving over poorly drained areas. So if you have a site that's, clay soils, shallow water table, or bedrock, there tends to be more runoff from that site under existing conditions. So when someone comes in and develops it, if they didn't do any stormwater management, they would be making runoff worse. They would be generating more runoff at higher flow rates more often, and people downstream would feel those impacts, but not as much as a more well-drained site where under existing conditions, a lot of that rainfall never becomes runoff to begin with. So, is this bold statement here something that a designer is going to come to a site and say, well, I don't want to do a lot of stormwater management, so I'm going to build my building and parking on the poorly. No, it's usually not going to come into the discussion. That would be nice, that if that were the case, but there are other real world constraints that dictate where someone's going to put the pavement or not. It is a consideration. I'm not saying it's not useful, but it's usually not going to be the driving force in someone's site layout. But it's a very important consideration for reasons that we're going to talk about in a little bit. So looking first at runoff quantity, and I have the guaranteed success here. It says set the bar as low as you can, and the corgi hurtling over the bar that's barely off the ground. But this really, you've heard the term, moving the goalposts. This is why existing conditions are so important. So that hydrologic soil group, that HSG, we'll talk more about. Maybe you've heard that A, B, C, or D soil types. The land cover and the topography must be properly represented. And from your stormwater management design, the storage, and I don't mean permanent storage, I mean the size of your detention basin, the size of your bioretention basin, the size of your underground infiltration system, is going to increase the more permeable your site is, just like we just talked about, the more vegetation you have under existing conditions, and to a lesser extent, the flatter the drainage patterns. And all three of these factors go into defining the volume and the rate at which water runoff is generated from your site under existing conditions. So that temporary storage you need to hold that runoff and release it slowly is highly dependent on these. Now, from the groundwater recharge standpoint, here again, the existing hydrologic soil group, and land cover must be properly represented because they have an influence on the amount of groundwater recharge that a site currently provides and that the designer needs to provide in the post-development condition. Similar factors affect this. So the more permeable the soils are, the recharge volume increases. Somewhat counterintuitively at first, that recharge that you have to provide actually decreases the more vegetation you have on the site. And that should seem counterintuitive to you, but the distinction is between groundwater recharge as it's defined by the state and infiltration. Those are not the same things. In fact, they're very different. And that might be news to you, and I'll explain what I mean later. But yeah, so vegetation is kind of a ding both in the existing conditions and in the post-development conditions. You, in some cases, can get penalized for the vegetation, which I think is unfortunate. So yeah, one other kind of side note, just because I know we have the diverse audience here. When it comes to existing conditions, you know, even in the last 5 years, there's widespread availability of aerial images that's at your fingertips, at your desktop. The frequency, I mean, you can, depending on what services you use, whether they're free or some of the pay services, the frequency of these images, the resolution is just increasing exponentially, continues to. There's no real excuse for guesswork here anymore. Not to mention the street view images. If you have questions about existing conditions, we frequently use them. Sometimes an application won't tell us where their test pits were. Well, we'll look at the aerials and we can get a pretty good idea of where their test pits were, and you can see it. You can probably see it, here where the disturbance was. So it's a really good tool. I'm sure a lot of you already know about that and use them, but boy, it just gets better and better. So how a little bit more about runoff quantity, and this is what I refer to as peak flow control. This was I guess of the three performance requirements, probably the oldest. It's changed over the years a little bit. And there's three different ways to technically comply with it. And that might be a surprise to you because probably more than 90% of the time, designers, whether you're a designer or reviewer, you're going to design or review applications that feature a 50, 75, and 80% reduction for the 210 and 100-year storm of the pre-construction peak runoff rates. And again, pre-construction, that's your existing conditions. That's why it's so important. Occasionally we'll see one that follows B1, the top one here, do not exceed at any point in time. I'll have an example of that on the next slide. That's unusual. You see that more with redevelopment applications. I haven't personally seen one that has gone with the B2, and for good reason. That's a pretty heavy lift. And I won't go into any more detail on that. But yeah, that first one, do not exceed at any point in time, kind of a misconception I've seen there is that you can just calculate your existing conditions runoff, calculate your proposed conditions runoff, and just go with it. The peak here is less than the peak there. I'm good to go. And this is one that just came across the desk this week. And this application, that's all they provided. And that's not going to cut it. At any point in time, in the DEP, in my experience, has been strict with this and treated it as literally a black or white issue. So what this applicant should have done, this engineer, is actually overlaid their total proposed hydrograph and their existing conditions hydrograph. And had they done that, they would have realized quickly that they did not exceed at any point in time the pre-construction runoff hydrographs, and instead they're gonna find that out the hard way. So that's one that's a little harder to meet than it sounds on the surface. Another thing that's, I guess, somewhat new in some ways, and I think there's been some clarification on this. Gabe he had a good example of this on one of his MS4 audits, with the section of not just the apron, but also a considerable section of the parking area that was not being captured. The runoff quantity standards shall be applied at the site's boundary to each abutting lot, roadway, watercourse, or receiving storm sewer system, which means, perhaps for a site like this where you have a huge warehouse or something, and you have multiple discharge points, even if they're literally going to the same water body, and you maybe only have one other property owner between your new impervious cover and your receiving water body. In the past, what would be done here is one single system. But what needs to be done here, for a couple reasons, the new green infrastructure rules being one of them, but this requirement also ensures that at each discharge point under existing conditions, it's met. So you'll end up with something that would look more like this with a compliant system. Now, this brings another topic up that, again, I think is less of a black and white issue, but another thing that that has come up, not a lot, but I've seen this a few times, sometimes with some dramatic results, are how we define peak flow control, runoff quantity again, and how we think about it in terms of existing drainage patterns. So Gabe just said that you have to meet the peak flow reductions at each of your points. And when you develop a site, you can't exactly maintain drainage patterns precisely. You're taking some kind of natural topography and you're putting a relatively flat, parking lot or, a building with a roof line in. But there should be some respect to the existing drainage patterns. And here's my argument why. And I think the rules do account for this. Maybe not in the black and white fashion that we like, that makes us comfortable. So we strongly relied on the peak flow reduction, those 50, 75, and 80% reductions. But remember, those rules only cover up to the 100-year storm event. And we all know in recent history, especially, that the 100-year storm event is not something that never happens. It seems to happen more than it should right now. And, in a given 30-year period, you've got a, 20, 25 or 20 or 26% chance of it happening. I mean, these things do happen. So typically, what do we do with storms greater than the 100-year? We have an emergency spillway, and literally whatever comes in goes out. The runoff quantity only talks about the 100-year storm event. And so typically your outlet structure, like the one here from a classic detention basin here, is set at that elevation so that, the 100-year storm is just lapping at this emergency spillway. But does the design engineer or the reviewing agency's responsibility end there? I mean, my answer is no, and here's why. So what if a design application, and there's one pictured here and there's another one in my mind, fresh in my mind. What if during the design, they take a large amount of drainage area that currently goes to some small tributary, out one way, and the rest of the site goes to another tributary, and they take that drainage area and bring it to the other, transfer that drainage area. Well, there might be some issues. Certainly someone who lives downstream of the drainage area that the runoff was taken from has no complaint about additional flooding. In fact, conditions are better from their perspective. But on the other drainage area, they still have to meet that 100-year, 20%, 80%, reduction. But when the storm bigger than the 100-year comes, now they don't just have that same, say, 10 acres coming to their site. That's that used to be wooded. Now they have a developed 10 acres plus maybe another 5 acres that never came that way. And the rules don't directly say anything about that other than that you need to account for drainage area and drainage patterns, which I think is a pretty strong statement. And again, you're never going to perfectly match that drainage divide pre to post, but these wide, far-reaching diversions, intentional diversions, I think create a problem when we think beyond the 100-year storm, which unfortunately we're having to do more often. Okay, so that's that. Another one that I have seen overlooked is closed depressions, and I'll talk about what that is. It's kind of a unique situation. I see it in maybe 10 to 20% of applications, more than you might think. And I'll tell you what it is. But the rule reference here is that when you do those existing condition calculations, again, we're talking about existing conditions, we're talking about setting that bar at the right place, you have to account for such features as ponds, wetlands, depressions, hedgerows, or culverts that may reduce stormwater runoff rates and volumes. So what does that mean? What is a closed depression? What is that definition there, that requirement could encompass a lot of things and does encompass a lot of things. So a closed depression is a topographic low point, a puddle, if you will. Not a small one that you might step on the side of the curb or something, but in the landscape, it's a bowl. It may or may not have normal water. It may or may not be a pond. It may or may not be a wetland. It could likely be both of those things, but it could just be a low point. And these function as an existing stormwater control, and the post-development peak flow rate reductions must account for that. So in other words, your site has its own detention basin to start with, and you've got to take that as your bar and reduce it below that. You can't ignore that feature. So what do they look like? I mean, usually it's just a road crossing and maybe a culvert where there's some fill across the natural drainage pattern. Parts of the state that had the benefit of glacial landforms, they carved out a lot of these. This is not an example of one of those. Very small portions of the state, we have some karst bedrock that dissolves and can create these closed depressions. But they can very well be man-made too, and most of them are man-made. This is an example of a man-made one. Okay, you might not see it. It might not look like much, but it's a half an acre that can hold about a foot of water in it, and that's a substantial amount of runoff. When we start talking about maybe the 2-year storm, maybe the 100-year storm, this isn't so as big a factor, but they do need to account for these. Sorry for the low quality here, but notice and this is an extreme example where you have 2 wetlands and you have all these concentric rings of topography, and that means that runoff is, converging and not going anywhere into these low points. So these are closed depressions, and in this example, the peak outflow for all storms, even for the 100-year in this case, was 0. They could not discharge any runoff. And of course, the original application came in and completely ignored these. So it totally changed what they had to do. And all the neighbors, and you can see there are some neighbors here, have been benefiting from these natural features on this site. And again, whether they're natural or not, for many years. And so it's important that when, as a designer, we come in here, we account for the benefit that the site was already providing for these for the neighbors. So what about from a groundwater recharge standpoint? Remember the code did say rate and volume. So the groundwater recharge spreadsheet wasn't developed to account for these kind of things, but that doesn't mean, and that's certainly not an excuse to meet the rule. You can account as a designer, as an engineer, you can account for what these closed depressions were doing in terms of groundwater recharge in other relatively simple manners. It's certainly not an excuse. So those are important. So some real world examples. Now this one is another one that was before the green infrastructure rules, so some things would be different here. But consider the case here of a fuel station and very small convenience store. Pretty well packed in. We've got a regulated area to the planned north, retaining wall there in red, septic field here, underground stormwater system here. And if we just open this up and did what probably, unfortunately, a lot of reviewers do, and I'll look at this from the reviewer standpoint because that was the role, we go to the table that summarizes the peak flow rates, and we see that, okay, 100-year, they got a 70%, we only needed 80, they're good there. The 2-year, they hit their 50%, we're good there. Let's move on. And what I would say is slow down. Let's see what's going on here. So this site was mapped as an urban disturbed units that we see more and more, as we live in the most developed or most densely populated state. A lot of the development is occurring on sites that aren't, that have been impacted in some way, shape, or form. So the engineer applied hydrologic soil group D soil conditions to the existing conditions calculations, which wasn't a crazy thing. They went to the soil map and it said it was urban disturbed soils, and it probably didn't have any HSG applied. But the reality is that the site is surrounded by A soils, and the other reality is that they had designed their geotech, they had designed their septic system and done a ton of borings on site, and the site was extremely well drained, 30 feet to groundwater, 20 or 30 feet to groundwater. Sandy soils throughout the whole profile matched the native soils, the native A soils that surrounded the site. So they had their own data that proved that the site was A soils. So what difference does it make? A big difference. So here's an existing calculation for this site with D soils, which is what the engineer proposed, at about 8 CFS leaving. I forget which, I think this was the 100-year storm. And with A soils, you just had this little blip of runoff that was less than 1 CFS. So if I need to design a detention basin to take my pavement, my 80% paved site or whatever it was, and knock it down to below 1 CFS, that's one thing. And it's a totally different thing if I can just ignore that and can discharge as much as 7 CFS. And in this case, that had a real bearing, frankly, on what the applicant could do with the site to begin with. Because they only had so much room, and they only had so much room underground here too. So this is the extreme example from an A to a D, but significant differences exist between, for example, a C and a D as well. It's not trivial at all. So for this reason, or for some other reason, the HSG, the soil reclassification seems to be, I think I see it in about 50% or more of applications that I'm asked to look at after the fact. Seems like everyone disagrees with the NRCS, and frankly, the maps are pretty good. Every time I go to a site, look at a test pit, I usually see what the maps say. But the BMP manual has a detailed approach on how to reclassify soils. If you find that it's a C soil and you really think it's a D, and the approach relies on and references the well-established NRCS method, and I've given you a link there to get to it. And that method is fairly simple. I don't know, it's like a 6 or 7 page document, and it boils down to this table that says that you can't read, and I understand that, but it basically says check this depth to water table, measure the hydraulic conductivity, if then, and you work your way to the right, in the right column here you end up as either an A, B, C, or D. It's not, it is a black and white process. They have boiled this down to that. So my question, and this I think is what some people maybe missed the point on a little bit, is my question often, and again, everyone so often more than 50% of the time, people are asking to revise the hydrologic soil group. I don't think the maps are all that bad, but you have a problem with one of these bullet points. Are you disputing the accuracy or precision of the soil mapping? And what I mean by that is, okay, maybe this is my site, and I've got, one soil on this side of the line and one soil on that side of the line. Keep in mind that line, and I tell people this all the time, that line is not a line, it's fuzzy. No one went out and mapped exactly where that line should be. And you shouldn't expect to find one thing on one side and the opposite on the other. But it's a pretty good line. I just tell people it's a little bit blurry, you know? So are you going out and you're saying that my site's here and really the soil I find matches this soil series, not the one that's mapped? That's one question. But what I'm usually seeing in applications that I review anyway is they'll go to a site and maybe it's Penn series soils and they'll do test pits and they'll come back with a test pit log that just screams the Penn soil series. And the Penn soil series is established as whatever it is, a B or a C hydrologic soil group, and they'll say it's actually a D. So they're disagreeing not with the mapping about where the line is or what's on the site. They're actually disagreeing with the NRCS's opinion of the soil series that they established, which, the BMP manual doesn't get into these intricacies, but I raise a little more question on the second bullet point because that's really a different question than saying that they just got the mapping wrong. That's disagreeing with the definition of the soil series itself. So you need to understand what their dispute is, and I think oftentimes the engineer may not understand which they're questioning. So a lot of people do this revision, and one thing that I wanted to be sure to say is if they classify it as a D, they don't have to do any groundwater recharge whatsoever because the assumption is that none is occurring on the site as is. So you can see the impetus and perhaps why so many applications try and do that. Chapter 12 again talks about how to do it and also has some detailed guidance on exactly how many to do. And it gets it as close to a black and white issue as it can, but not all the way there. But remember, and this is another misunderstanding I see quite often, this testing is not to determine if a proposed BMP will work. Like you don't just do two tests where your basin is, say, you know what, these are D soils in this small corner of the site, therefore the whole site is D. No, this defines the existing condition and sets the bar for the whole site. Therefore, someone comes in with this argument, they better have tests over the whole site, not just where they wanted their stormwater system to be. So I'd like to pause there and let that sink in a little bit. Maybe I have a question on that later, but that's a pretty big point and something that is often misunderstood.
So Clay, as
Yes.
that's sinking in, I do want to go to that because that is something I see a lot of applications with no soil testing and with the condition that it's done later. So to reiterate what you just said, sort of
Yeah.
make the first step of a design is do your soil testing so you can identify those areas where BMPs may work and
Right.
then design the site around that versus what I think happens a lot is let me design the site and then figure out where the BMPs with what's
Yeah.
left over.
Yeah. And that goes back to the point I made earlier about, paving over well-drained versus poorly drained sites. You know, are these really the questions that dictate site layout, or is it access points? There's a lot of other things that come into play, but if you get too far and don't do what you're suggesting, you may find yourself painted into a corner that you don't want to be in. Um, and that's going to be no one's fault but your own if you're a designer. So, yeah, a really good point is something that's worth, again, more attention than we have time for. Um, Runoff quantity. So I'll get on my soapbox a little bit. I think that's an unfortunate name, kind of like my own in terms of infiltration. People tease me about that all the time. Clay, you're talking about infiltration. But quantity, it doesn't regulate the quantity of stormwater runoff from a site in any way, shape, or form. It regulates the rate at which the runoff leaves, especially with the fact that most people do the peak flow reductions. It's not reducing the quantity or the volume, it's reducing the rate. And, that's just what it is. I'll deal with it. That's the name of it. But keep that in mind because I do think that results in some misunderstanding upon people who are in important places, important roles, and they're not engineers, which is fine. We certainly need those people, but the term quantity is confusing. Groundwater recharge requirement doesn't regulate the quantity of runoff leaving a site either, and that is probably surprising to some. So a little bit about the New Jersey hydrologic cycle. And this is, I'm going to tie this into the things that I just said, which probably, if we have 100 people or so on this, I think it would be fair to guess that, 20 or 30% of us, this slide is eye-opening, that the water quantity has nothing to do with the amount of runoff that a site is going to generate, just the rate, not the volume, not the number of gallons or whatever. And the fact that groundwater recharge doesn't do that either. That's probably surprising to a lot of us. So here's the hydrologic cycle, and I actually grabbed this screenshot from the cover of the reference I gave you for the hydrologic soil group, the National Engineering Handbook. Just was staring me in the face, and I said, you know what, I better pull that into the presentation because I can talk about that. So let's look at New Jersey. And if we take our 45 inches of rain that we get as a state on average and slap 100% on that, and just think about that, 100% is our 45 inches of rain that falls from the sky. More than 60% of that 45 inches, so more than, we're probably talking around 20 or 30 inches of that rainfall never ends up running off, never ends up in a stream, never ends up flowing into the ocean. It, frankly disappears into the atmosphere by evaporation, but mostly transpiration from plants taking up water into their roots and putting it back into the atmosphere. And where does that number? Oh, your mileage may vary, right? Depends on where you are in the state. A lot of other things going on, but there's been a couple USGS studies, long-term studies. I didn't make that number up. It's surprising to me, even as an engineer. I think to the layperson that would be surprising too. It never, makes its way into the stream. It literally goes back up into the atmosphere. Now, in New Jersey, we do have this groundwater recharge requirement, but remember, if we look down here, and there's some stuff going on in this image that I'm not exactly sure, but some squiggly lines here I think are supposed to be roots and things. Statewide, on average, how much of that rainfall, just in a percent, how much of that 45 inches gets into the deep groundwater table? Groundwater recharge is defined, and some things get a little blurry here, and this can vary drastically depending on where you are in the state. But maybe it's about 10 or 15%. I don't know. I put 12% on it. So what this means, number one, is that under existing conditions, everything that infiltrates, that doesn't become runoff, doesn't necessarily become groundwater recharge. A lot of it is taken up by the roots of the plants and put back into the atmosphere. It never ends up in your stream, never ends up flooding your neighbor on an annual basis. It goes up into the atmosphere. And none of our rules address any of this. It's just the way it is. Some states do, New Jersey doesn't. The groundwater recharge says that you got to maintain this, again, 12% on average. Maybe it's 0 if you have D soils, or maybe it's 15 inches a year or something. We do have this rule, the groundwater recharge requirement, that we want to maintain those groundwater resources because we use them, quite frankly. Throughout the state, people rely on groundwater. People and other things rely on groundwater. But there is a distinction here that I think is important. And if you don't believe me about the 60%, bear with me for a moment. So here's two graphs. The one on the left is Atlantic City precipitation. And the point of this graph, this happens to be 2022, last year's annual rainfall in green. It was a pretty average year. And average or normal is this brown line. 2018 was extremely wet. We had 70 inches. And for those of you who remember, 1965 was dry. That's just what these other lines are. The point of me showing you this is that the brown line is pretty straight. We don't have a wet season. We don't have a dry season. It rains about the same amount in every month here. Other parts of the country, not so much. But if we take the runoff from a stream gauge and we convert it into inches, which we can do, we don't need to talk about how, and we divide it by the precipitation in inches, we see that it's less than 1, right? I've just zoomed in here between 20% and 70%. And this time of year, we're hovering at about 50%, about half of what rains down flows out of a stream. Again, not at the site scale, but on a watershed scale. But look at this big undulation here that starts up in April, especially May, June, July, and August it peaks out. So this is when all that evapotranspiration is happening, 60%, probably more, is happening in the growing season, and that's because of that vegetation. Okay, so that's the big difference there on trying to differentiate between runoff quantity and true volume control that we don't really do. So I think that's a big difference. So if you look at a typical application and you look at the runoff volume from the 2-year pre to post, you're probably increasing the runoff volume even with a compliant stormwater system, threefold. Maybe in the smaller storms like 2-year, even more than 3 times. And in the 100-year, you also have increases, not as much as in the smaller storms. But we still need to just limit that peak flow rate here. So Gabe talked about a little bit of these. This is just some background. The green infrastructure rule, in my opinion, is still relatively new to both designers and reviewers alike. The DEP has a great frequently asked question and other resources on that I encourage you to look at. But we do have this drainage area limitation, and I think that has led to some misconceptions, if that's what we're here to talk about. And Gabe mentioned that he thought a little bit of that was because people had development plans that already had concept plans, so they were taking BMPs and kind of trying to turn 1 into 4 and keep them in the same site. I agree with him, but I'll add to that and say that the engineering profession, probably like all of them, has momentum. And sometimes that, I think of it as a barge, sometimes that momentum is a good thing and sometimes it's not. And the barge will go in the direction that it needs to, but it might take a little time to get there, to start up and start moving. And I think we're seeing that in the green infrastructure rule. We're seeing that momentum. We're seeing that understanding. Not everyone is taking these, webinars from the Watershed Institute, but like you, but we're getting there. So yeah, again, as he said, treating it close to its source, and that's where that drainage area limitation comes in. So the idea was to take applications that used to look like this, taking 30 acres and bringing it to 1 detention basin and making them look a little different. You'll still see some like this, but this system will need to be some kind of green infrastructure, and you will need to have some other water quality or groundwater recharge systems dispersed throughout. So you will still see some big basins at the bottom of the project, but there'll be more to it. You won't see something exactly like this anymore. So this is another example. I've tried to cartoon this one a little bit to protect the innocent here, or whatever you want to call it, and to make the point a little clearer. So and tried to model this after some of um, the guy who put this together, I should say, tried to model this after some of the DEP guidance that Gabe went through. So yeah, they have their 3 BMPs, but they're literally right on top of one another. And this is post green infrastructure, so this is not something that will fly. And you can see that they had opportunities to do things in other places. But maybe this is another case of that momentum. And then we also have some people getting a little more creative, where they're taking drainage areas that are up here at the top of the hill, and instead of doing any stormwater up there, they're taking the green area and putting it into the green BMP down here, the purple area and piping it to the purple one down here, and the yellow, and so on and so forth. So they've taken one basin and literally put retaining walls in it and made it five basins, 6 basins technically. Anyway, definitely not what was intended. Hopefully we'll see this kind of stuff less and less. So another green infrastructure thing, some of the MTDs and manufactured treatment devices comply with green infrastructure or meet the definition, the soil definition. So think Filterra units and things like that that have some soil and vegetation. And so, you get an MTD and you get an MTD and you get an MTD. But are these things really going to work the way you intended them? Is runoff really getting into all these systems? And then more importantly, the MTDs still need to work. And this could be like kind of a gray area. Where in the code, does it say, that you can't do this, or where? But here you have a couple of those same MTDs proposed, and you have a normal water surface of the proposed stormwater system that will keep these things saturated. And that's not the way they're intended to work. And never call a manufacturer to try and get an honest opinion on how their system might not work, because they'll never tell you that. But if you understand what the system's supposed to do, you'll know that these things need to have a certain amount of relief so that soil remains aerobic and doesn't go anaerobic and become an actual source of water quality pollutants. So they still need to work. You can't just stick them everywhere and anywhere, and you'll see applications going in with dozens and dozens of these things. You're going to see them popping up more and more because it's a quick and easy way, and they're usually under that drainage area threshold. And I'm not saying they're a bad thing, they just need to be done right. So kind of to close with that, and this was something someone that Mike shared with me, recent application that, with a basin that still had the concrete low flow channels, and, bad habits die hard. And there are, some, like I said, some momentum in the profession that we still do need to overcome. And finally, I wanted to go a little bit more into infiltration systems, and I found myself just going down a rabbit hole with that. I do want to point out, Gabe mentioned that now you are allowed to use account for the infiltration from your BMP in your runoff quantity in your peak flow calculations, and that's a relatively new option, and it's a great thing, but you can only account for that under very specific circumstances. So what we're seeing, if we want to talk about misconceptions, is even without soil testing, even without proper separation from groundwater, even without doing what's called a groundwater mounting analysis to ensure that your infiltration system is going to work, people are just accounting for it. And it can really help them, especially in, say, the 2-year storm, or especially if they're going for some different ways of complying with the runoff quantity, specifically that at any point in time requirement. So, yeah, so Chapter 13, it's a relatively new section of BMP, man, a few years now. outlines how to do those calculations to ensure that your system is going to work and can be accounted for. And I just want to say not everything that looks good in plan view is. So here, it doesn't look bad on paper. You've got a building, parking area, they got some pervious pavement, and they have a subsurface infiltration system. And yeah, maybe these things are a little close, but they are large and they, kind of spread out, at least from what you see here. But, on the paper, this is just a line, right? This is just a line. What could that possibly harm? But if this is a 12-foot retaining wall and you have pervious pavement right up against the back of it and a subsurface infiltration system here, and all these BMPs are built in fill, is this really the best design? Is this really going to work? And where exactly is this non-compliant? I think it is non-compliant, and I don't think it's going to work. But again, just on a flat piece of paper, sometimes things look okay, and we really need to think about the site as a whole and look at how things fit together. So with that, Mike, I guess I'll stop here. I think we're in good time for a few questions.
Oh, yeah. And Gabe was very busy answering some questions.
Awesome.
And I'll go through a couple of them, but I'll start off with a moderator's prerogative. We covered a couple of them, but I think they need repeating. Quantity control is not actual volume reductions, it's rate reduction. The way our rules currently work, and please disagree with me if I'm wrong, because I am not an engineer. I'm a lawyer who can't even add up timesheets. But when we create impervious cover, we're increasing in many cases the volume that is running off the site. And I hear applicants say this a little bit less in planning board members repeating this, but quantity control is going to make the flooding better. It's not necessarily. There may be circumstances possibly in this state where flooding was worse and the development will make it better, but by and large, that's not the case. And then I see a lot of resolutions out of planning boards saying, well, soil testing and infiltration testing is a condition of approval. And I think, Gabe, the example you gave of the site that got built not according to the plan sort of demonstrates, I think, indirectly the concern I have with that is if we assume the design is going to work, but the testing afterwards shows it doesn't, what do we do? And I think that's why it's so important to get that testing up front. I think that's why it's so important to get that testing done before even the site is laid out, so you know what you're dealing with.
Yeah, I have to agree entirely with that. At the department level, we wouldn't even accept an application that was submitted to us without soil testing because just like you're saying, you can put anything you want on paper. If that's not the soil that's out there in the field, your basin doesn't work and you have to completely redesign your site. Most times you can't just change your basin to another type and suddenly it's going to meet all the requirements. You're going to have to completely redesign your stormwater. You might have to move buildings, parking lots. It's going back to the drawing board on everything.
Yeah.
Yeah, I unfortunately I see that a lot. I mean, I think some things can be worked out, understanding that planning board members are not engineers. Certain things that, can be fixed on a plan or designs, but some very basic stuff needs to be there. Gabe, there was a question earlier, and this is an issue I have always had. Our stormwater rules deal with TSS in nutrients to the maximum extent practicable. I never found a site plan or stormwater design that actually addressed explicitly addressed nutrients, but they never address oil or hydrocarbons. And there are many plans, parking lots, maintenance lots, where could be a real issue. And there's one commenter, and I know you answered it. Their EC always recommends an oil water separator, but that recommendation always gets rejected. So is there anything people can do about that? And is there, do you know sort of why hydrocarbons is not sort of one of those things that are specifically called out in the rules?
Well, as for why it's not called out, I don't want to call it exactly a surrogate, but the presumption is that if you're going to be able to remove 80% TSS from the stormwater with whatever BMP you wind up using, that you're going to remove a significant percentage of whatever other pollutants you're talking about, whether it's nutrients or petroleum hydrocarbons, are also going to get some percentage removed. It's probably not 80%. So, in fact, it's almost certainly not 80%. But let's say you use a bioretention basin, you might get 30% phosphorus removal from that if it's going to get you like 80 or 90% TSS removal. So you're still going to get some reduction in those other pollutants, including any petroleum hydrocarbons. Now, it can be a little bit of a complicated situation to explain why we don't have more stringent requirements there. Basically, if you look to the NGIPD's rules, it'll talk about how stormwater from residential and commercial developments is basically cleaner and it's exempt from a lot of our NGIPD's permitting requirements for those types of properties. But if they happen to be an industrial site, then it's a whole different story. So an industrial site ends up needing an NGIPD's permit if they fall into a regulated industry, and that's through our industrial stormwater program. And in those cases, oil water separators are extremely common to be required. And many times those permits come with limitations where they actually have to sample their stormwater and show particularly the petroleum hydrocarbons, because that's in our rules. They can only discharge, I think, 10 or 15 milligrams per liter when they test it. So that will actually be in those permits. So if we're talking about industries, we certainly have a pathway where we can get them to do something about that. If it's residential, commercial, it becomes much more difficult. Now, like I'm responding to the commenter, if that is something that your community wants to require, you can conceivably put such a requirement in your stormwater control ordinance. It's very difficult to enforce something, probably not legal to try to enforce something that's just not required by your ordinance or by the rules you're implementing. So if you want to do it, you got to put it in your requirements.
Very good. And then there's a current live question. How can groups ask to see the stormwater BMP for a building proposal? So now, if this is a project that is being considered by a planning board or a zoning board, those documents, the designs, the maintenance manual, all of that information should be available at the township. Most townships have that available on their website. You may have to dig around to find it. A handful of them don't have it electronically, and you have to go look at it at the township, but most towns have moved forward. So if that's sort of answering the question is great. If not, Laura, sort of clarified a bit. Most towns, and that has been one of the benefits, I think, of COVID, is most towns have all of the application documents available online to look at. The days of sitting in a clerk's office, thumbing through files, standing at a desk is mostly gone. And Clay, you both addressed this a little bit, but I wondered if you could talk more about it. So systems need to be distributed and closer to the source, and that may mean they may be close to each other. And I'm wondering, as you're looking through those things, concerns of having two infiltration techniques right next to each other. I see that a couple times, and you kind of wonder, are they going to impact each other? One's higher than the other. Are there things to look at and think about when you're reviewing those plans?
Yeah, I mean, we can't put things at the four corners of the site. There's always going to be, every applicant's trying usually to get the most out of their property. So yeah, definitely you'll have things overlapping. One thing I point out is the mounting analysis, the way that they work. And again, this is where you try and determine what influence the infiltration system is going to have on the groundwater table. It's going to make the groundwater table rise by definition. And so you want to make sure that doesn't impact, say, a neighboring property that might have a basement, or the proposed property that might have a basement. So you can do those mounting analysis for the separate infiltration systems that aren't that are maybe close to one another, whatever close means. And you can add them. You can take the curves right out of the tool and add them up. That's pretty much how it'll work in real life. So there's some things you can look at like that. And you could also do that for, say, like that retaining wall example that I showed you. Um, so, um, yeah, definitely some a good question and something to keep in mind.
Right, and you can use that added mound up to look at the basin itself too, right? So if you have those two basins close to each other, you add the mounds up and you see, oh, now it's going to reach up into the bottom of the basin. Well, now you know the basin's not going to drain in the 72 hours that you used in the model, if you did. I mean,
Yep.
if you're
Yep.
trying
And
to see if it'll
that's
drain in 72, you got to stretch it out to 72 hours and see what happens. But
yeah. And that's the main reason, or maybe not the main reason, but that's one of the key reasons you use that groundwater mounting analysis is to make sure that the basin is actually going to not interfere with itself.
yeah,
And the reason that we need that is because we're in New Jersey. We have a big part of the state that's in the coastal plain. We have, shallow groundwater in a lot of places in this state, and the requirement has always been 2 feet of separation. And historically, let's say 10 years ago, the assumption was that if I had my separation, of course it's going to work. But that's not what that 2 feet of separation is for. And the 2 feet of separation doesn't necessarily mean that it's going to not interfere with itself and mound and hold water for extended periods of time. Um, so that's why
yeah.
that's so important.
Many examples where the 2 feet is just not sufficient for a
Yeah.
basin to drain in 72 hours. It definitely happens in the coastal plain, though it's not as common there because you have the sandy soil, so the water can disperse laterally really quickly. But when you get into areas where you've got, I'm not doing it so much in D soils because the basin's never going to work there, but you have C soils where it's just on the border of being able to have an infiltration basin and the water just can't spread laterally very quickly. So it just builds up underneath the basin and just doesn't allow it to drain in time. That's where we see those not work. End up needing 3, 4, 5 feet sometimes. Of course, it depends how big your basin is too. The other solution is expand the footprint of your basin so you're stretching the mound out around and your infiltration out instead of trying to do it in a more confined area, and that helps it to function better. So when you have those soils that are questionable, you stretch it out, it's more likely to work.
Yeah.
Great. Well, thank you. And I will leave with two last thoughts. Again, we briefly touched on it. That water table, that mounding analysis, making sure that those soil tests are done so your BMP has that 2-foot separation where there is an infiltration requirement. Again, a lot of times I see that as one of those, well, figure it out later, and that's not necessarily appropriate. But Clay, Gabe, thank you so much. That was, once again, I learned a lot on this. I hope everyone else did. If you are an engineer, again, there was a attendance form. Please submit that. And we will give you professional engineering CEUs. I will put a plug. We have our upcoming watershed conference for professionals, environmental advocates, community members, municipal officials, all about watershed and regional planning. All of our towns are working towards a watershed improvement plan, which hopefully we do in a regional approach. And we're going to start that conversation on February 23rd at the College of New Jersey. More information you can find on our website. And again, everyone, thank you very much. Clay, Gabe, thank you. This was wonderful. And I appreciate everyone attending all of our Technical Fridays this year. And we will be announcing some new ones for next year, early next year. All right, with that, we're going to end on time. So thank you again. Everyone have a great day.
Thank you.
Thanks.
Take care, everyone.
Take care.